So, your Steadicam is in perfect static balance. Fore aft, side to side. Couldn't be better. And yet when you do that whip pan, ooh, ouch, the horizon just doesn't look good. Well, that's because although it's in static balance, it's not in dynamic balance. What I mean is, if I spin this rig, yeah, it gets ugly very quickly. So why is that? So let's just have a look at the difference between static balance and dynamic balance. What I'm going to do is a little demonstration, just using two masses to show you where things start going wrong. And here we are. Imagine this is a very simplified version of your Steadicam. We're ignoring the third mass. We just have two masses down below. We have the battery, we have the monitor. They're both at the same level, and this is in static balance. It hangs, the post hangs vertically. But when I spin it, it behaves pretty well. It just spins flat. If I take the same situation where I have moved one of the masses up so that the masses are not coplanar, it's still in static balance, but when I spin it, it starts going crazy, just like the Steadicam did. So, what we have in a normal Steadicam is we have the batteries down fairly low, because if the batteries are up high, they tend to hit the Steadicam arm. They interfere with your work. And also, being down low, they help you balance heavier cameras. But you don't want the monitor all the way down there, because you're straining your neck down to look at it and you're having to look over the arm. You actually want the monitor up somewhere more comfortable. So typically, the batteries are lower than the monitor. So how do we get dynamic balance? Well, fortunately, we have three masses to work with. So as well as just having the battery and the monitor, we have a camera, yeah? So if we want to move our monitor up somewhere where it's more comfortable, yeah? We're not stuck in the two mass situation, we've got a third mass, so there's something we can do with this mass to bring it all back into balance again. So what could it be? Well, here's a very simple and kind of stupid kind of thought experiment that helps understand what's going on. If, for craziness, I were to move the monitor all the way up here, which of course would never work, but just imagine that if we were, how would I arrange the other two masses to make this work in dynamic balance? Well, what I'd have to do is put the battery in here, and I'd have to put the camera out here. And we have the same situation as we had before, where the three masses were in balance, but we have it just with these other two masses at the top, instead of two masses at the bottom. So, bearing in mind what we just did, what we can do is think about the same thing, but doing it incrementally. So, as I move this monitor up, I have to move this battery in, and I have to move this camera back, yeah? And just imagine it like a circle. The same direction the light goes in the lens, yeah? A circle. Every time I move this monitor up, I move this battery in, I move this camera back. Okay, so let's see how that works in the real world with a Steadicam. So, when you get the camera from the camera department, you want to make sure it's completely built with everything that's ready for production, whatever you're going to use, map box, focus motors, whatever, it doesn't matter. Just make sure the camera is completely built, and then get a rod and look for the center of gravity of the camera. Yeah? Now I've marked it here with this red tape, the center of gravity of the camera. If you don't have a rod, there's always something you can use, yeah, to find that center of gravity. Then what you want to do is you want to put the Steadicam plate more or less in the middle of the center of gravity. Don't forget, you should also center it side to side. In some cameras that means putting it a little bit like this or a little bit like that, but you're looking to try to get the center of this plate in the center of gravity of the camera. Okay, when you've got that marked, and you really must do this as a first step, you put it on the Steadicam. Yeah? Now, what I'm going to do is take the center of gravity, yeah, and I'm going to move it back a little bit. And just for the sake of this exercise, I'm going to make it level with the back of the post, because it just turns out that for most Steadicams, that's a pretty good place to have it. Then let's have a look at the static balance of the Steadicam. It's a way off, so I need to move some weight somewhere. A good trick is to get it back into static balance is move something uphill. If I move the camera uphill, it'll work, yeah? If I move the monitor uphill, it'll work. If I move the battery uphill, it'll work. But I've put the camera pretty much where I want it, and I've got the monitor pretty much where I want that, so the obvious candidate here to move is the battery. So I'll move the battery in, get it roughly in balance, and then check my drop time. Because if it's very bottom heavy, then it's just going to pretend like it's in dynamic balance when it isn't. And if it's very, very neutral, the dynamic balance is going to be harder and harder to find. So the drop time, we measure, not 1, 2, a little bit slow for me. I'm going to take it slightly faster. Now, when you're measuring drop time, it's absolutely essential to get the post horizontal before you let go. Or is it? Not 1, 2, that's 2 seconds. What happens if we do it from here? Not 1, 2. Well, check out pendulums. So, here we have it. We have this almost in balance, statically. Now I'm going to move it onto the spin balance stud, just to finish it off. Yeah. And give it a little spin. And so we are fairly close. So what do you do in this situation? Well, you know that you're a little bit closer than you were, but you're not exactly right. So the best thing to do is just to move something one direction and see if it gets better or worse. So I'm going to move the batteries in about a centimeter. It's less than half an inch. Then I'm going to re-static balance the camera. Yeah. Going to move the camera back and then spin it again and see, are we better or worse? Yeah, well, we're definitely better. We're definitely better. If we'd been worse, I simply would have moved it back that centimeter and then another centimeter. Yeah. So do it a little bit more. Do it a little bit more. And try it again. And now, pretty good. Now, I'd fly that. I'd fly that. So what happens now? You have your rig beautifully, dynamically balanced. And then suddenly you have a lens change, where you put a big zoom lens on, or you take a big zoom lens off. Or in this case, we have a 24-volt battery stuck on the back of it. Well, you're going to think, is that going to throw off the dynamic balance? Well, it's not, because what is really important is the relationship of these three masses. And what you have to do is, now the center of gravity is on the green line. I've already measured it, yeah? What we do is have to put the green line at the back of the post. So, I'm just going to roughly do that now. And it's going to stick it up on the balancing stud. See how close we got? No, not quite there. Because I don't want to change the lower masses, yeah? Because I know that they're okay. But I do have to redo the drop time. And that's not a problem, because it doesn't matter where the gimbal is on the post. These three masses have the same relationship in space to each other. So if I move this gimbal and I fix the drop time to what I want, oops, we just had a little bit of slippage there. There we go. Let's try that again. So I have my drop time fixed again. And I just fine tune the static balance. Stick it on the spin stud. And give it a spin. And there we go. Not bad. Slightly off on the static. check the side to side. Give another spin. And there we go. Not quite, but not bad.